On this example, we're going to solve for all solutions in this equation with a sine and a cosine squared. In contrast to some of the other solutions in the review, this one we can't factor directly from the start. What we're going to have to do is leverage some identities to help us get there. So in this case, the cosine squared, I can apply the identity cosine squared x equals 1 minus sine squared x to this equation. If I do so, this is going to turn it into 2 times 1 minus sine squared x plus sine x equals 1. And after we distribute the 2, we get 2 minus 2 sine squared x plus sine x equals 1. Now what we're going to do from here is we'll go ahead and subtract over the 1. What we'll get is negative 2 sine squared x plus sine x plus 1 is equal to 0. Now if we divide everything through by negative 1, we can flip the signs around to make this positive 2 sine squared minus sine x minus 1 equals 0. And that's just a little bit easier to look at without having to have the negative out in the front. But now we'd like to factor and solve. So to factor, imagine this in the form of 2 x squared minus x minus 1. And if you'd like to practice your factoring at this point, you may want to pause the video and factor this trinomial. If we do, it's going to turn into 2x plus 1 times x minus 1. And that tells us how to factor our trig equation into 2 sine x plus 1 sine x minus 1 is equal to 0. Now we set each of these equations to 0. And we'll get something like sine x is equal to negative 1 over 2, and sine x is equal to 1. When we take the inverse sine to solve for x, we'll be looking for the angles that give us our solutions here. In this case, we're going to have x is equal to sine inverse of negative 1 over 2. X is equal to sine inverse of 1. And there are two angles for this one. X is going to be equal to, if we check the unit circle, will be 7 pi over 6 plus 2 pi k, also 11 pi over 6 plus 2 pi k. That's where sine is equal to negative 1/2. And then for equaling to 1, that would be pi over 2 plus 2 pi k.